Hello, we are the group 1407, and we will be presenting on the Koji wireless communication device. My name is Joe Larson.
I'm Tyler Todd.
And Chad Rourke.
Our advisor is Sammy Kahn, and our client is Mark Cromack and Matt Noah.
Okay, just as a background, we're working with a company out of California called Koji. They have an application available for the Android, which is supposed to replace note-taking. Just kind of a little picture of what their application looks like. They have a button that you can press, and it'll start recording. Not only when you press the button, back 15 seconds, and you can press it to stop the recording. So it's it's just supposed to replace having to take notes, which is kind of intrusive.
Go to the next slide. That leads us to the problem that they had with this app is that using your phone during a meeting can be intrusive. It can be kind of distracting, and it's really just inconvenient to have to pull out your phone and use it in front of everybody. Everybody knows what you're doing. If you don't look like you're highlighting something, they might think that you don't find it important. And so for that reason, they came up with the solution was to use an inconspicuous device, something that you could hold in your hand that would be small, that would function the same way as pressing the button on the screen.
All right, so requirements for this device are we needed to build a small one capable of controlling the basic functions of the Koji application, which basically is what a single button, start the highlight, stop the highlight. That's all that this needs to do. It needs to be of a small form factor, so obviously it's supposed to be unintrusive. It's going to have to be small in order to effectively do that. Needs to have an LED to indicate, start, stop, power, all sorts of things like that. Since there's no display, the user needs to have that LED to tell it the status of the device. Needs to be easy to use without looking at it. That would sort of defeat the purpose of the device if you had to look at it to use it. That's what we're trying to eliminate, so you can be fully attentive to the meeting itself.
So then that leads to, just the device has to be tough. It's something that's going to be small. You hold it in your pocket, you play with it in your hand and stuff. You don't want to lose it somewhere and have it get stepped on and broken, or just, it has to hold up to day-to-day usage. It would use standard non-rechargeable batteries. And then those batteries, they're going to have to last at least a month was the requirement. Because, you don't want to have to take the whole thing apart, put in a new battery all the time. We looked into using rechargeable batteries, but that wasn't a very viable option. It took a lot more than it would be worth to get that to work. Another requirement was that we construct the device in a modular fashion, allowing for us to possibly add features such as a built-in speaker. For example, Koji has hopes of someday taking this device and having it be more of a standalone. You'd still do the recording on your phone, but the actual speaker would be in this device, so you could have your phone tucked away in your pocket, and your phone wouldn't have to pick up any of the sound.
And eventually they'd like to even put it to like a pen or a watch, so that you don't even have to have a device itself.
It's more or less a proof of concept. That's what we've been doing here.
Exactly. Another requirement was that it had to use Bluetooth.
Low energy.
Yeah, exactly. Bluetooth low energy, because again, we want it to last a long time. And finally, the device had to be something that was capable of being sold on the market. You don't want to make a product that can't be sold. So. All right, this is just this is a picture of the SD1407, and that is basically the main building block of our design, of our hardware design, that is. There's a schematic of the final design. It's pretty straightforward, pretty simple. You can see kind of the main component there is the RFD22301, and then we have a red-green LED, just a couple peripheral resistor capacitor, and a SPST momentary switch.
And this chip is an ARM processor, and I believe it is the smallest ARM processor that you can buy.
M0.
With ARM0, and it is Bluetooth LE built into that, which is the main reason we chose that. So we didn't have to have an external Bluetooth chip and this all runs on the same voltage. The entire thing is just 3.3 volts, so we don't need any power regulators.
And the good thing about this too is that it's already FCC certified, so we don't have to go through all that. You can see that it's already got a little ceramic antenna built onto it.
Yep.
You can see, I guess in terms of main components, we have the switch itself, a red-green LED, and then the integrated Bluetooth and MCU module. In its active state, the power consumption stays within about 18 milliamps or so. During idle, while it's searching to pair or searching for a button to be pressed, it stays about a milliamp. And while it's just dormant, waiting for a phone to connect, it's the battery stays within about 900 nanoamps, which keeps us in that initial requirement of battery consumption.
Yeah. Should easily be able to last at least a month. And yeah, this next slide, it just shows there's our LED circuit, well, a simple LED circuit anyway, just showing even while the LED is blinking, it's still not drawing much, and even if it was drawing a lot, it's not drawing it for very long. So the LED, nothing in this is really going to draw much amperage.
The longest LED's on is about 1.2 seconds, and then that's only when you start and stop recording. So the LED is used pretty minimally. Yeah. There's a picture of our final PCB design, and as the label states, here's the antenna. There's the simple momentary on button. There's our red-green LED. Obviously the Bluetooth chip and module, and then on the underside is a simple clip that uses a standard CR2032 3-volt watch battery, which makes everything really nice. It all uses the same voltage, so you just need that one watch battery, dies, pop it out, put a new one in. Simple, cheap, pretty inexpensive, easy to do.
And to give you an idea about the size, the board itself is about 1 inch by 3/4 of an inch.
Yep.
Here's the flow chart for the software, how the whole thing works. Simple button that goes to the microprocessor Bluetooth module. Obviously, the battery connects to that. Based on what this button does, long press or short press, that's going to go to the Koji smartphone app and tell it what to do. It's going to send a string that says Koji start. Okay, they'll take that, they'll process it, they'll just start the recording. Sends a string if you long press, Koji stop. Stops recording. Pretty simple. Our red-green indicator for connection, long press, short press, and the Koji app will pair to this first just to allow this whole thing to happen, because the device won't do anything until it is actually paired to a smartphone app.
And this interface here is going to be done by Koji themselves.
Yeah.
So they'll actually interface that, our device into their application itself. So
We don't have access to their source code. That's all on their end. So they're going to have to integrate it into their app themselves.
All right. Well, there you got wireless Bluetooth communication. That's accomplished through a GATT service, and like it says there, that's abstracted through the Arduino built-in libraries. So a lot of this stuff, it's very difficult to do a lot of this stuff from scratch in Bluetooth, and so there it was really helpful to have the built-in libraries make it a little bit
several hundred lines of code just
yeah.
to have the Arduino built in, just Arduino BLE start instead of the 50, 60 lines of code just to set up the Bluetooth on the Arduino side.
Yeah, and just kind of understand the Bluetooth side of it. Bluetooth advertises, like it says, predefined services, and that basically just means that it has set things that Bluetooth can say that it can do. And so the idea then is that you pair to a device depending on what you want that device to be able to do. So in this case, the device is simply just send a string, basically.
Saying, I can send information, so if you can receive information, this is what I can do, this is what I can offer. And when you connect to that, when the phone connects to that, it says that it accepts that, and then it's able to receive that information from Bluetooth Low Energy. The design for the actual code on the Arduino side is it's just a simple interrupt that checks for a button press. While that button's not pushed, the thing is in sleep mode, so it's using, like you said, the 900 nanoamps of power. It can sleep for a very, very long time, and will only wake up once you actually push the button, and even then for about 15 seconds before it goes back into sleep mode. It'll broadcast that system event to the phone. Once that's done, it goes back into sleep mode. The phone needs to be able to recognize and receive that system event and handle it accordingly.
I guess here's some photos of our final product. You can see that the PCB itself comes out of the enclosure, so you can replace the battery on the bottom side. It is, like again, like was previously stated, it is a non-rechargeable, so you will have to replace the battery. These 4 screws hold the 2 parts together, and then you can see here that the LED, you can see the LED through a hole on the case, and the top portion is flexible enough to where the whole top is actually the button.
There were a lot of different problems that we ran into just throughout the whole course of this thing. It's a long project, you're bound to run into some things, and we learned a lot of lessons along the way. Some of those would be that, well, even in incorrect design can work for certain applications. Basically, yeah, that, like it says there, just means that proper testing is really necessary for certain, to be sure of having a correct design. There were some times where, like when we'd done our initial PCB print, we ran into a problem that we didn't see coming because it had worked right away when we tried it, but then later it didn't work when we tried it under the actual circumstances. And so it just, we got the result that we expected, but it wasn't for the right reason.
Yeah. Bluetooth is a lot more difficult than we'd originally anticipated, especially in the Android side. Even just to get it established on the Android side, several hundred lines of code, and there's no universal way to get it to work, which which I had fully expected, that there'd be a simple library, some abstracted stuff, and it would be wham bam, you're done. It's not quite so simple.
And if you look at the library itself, it's very cryptic.
It is. It's proprietary. It's strange. We could have put it on here, but it would be too much information. But yeah, the Android side, way beyond scope of the current knowledge. I didn't have enough time from the point where we understood that we were supposed to do the Android side to actually learn that discipline. Small bugs in code, they can become large ones very quickly, and that happened a few times where I would ignore some small issue. Oh, I'll come back to it once I figure this rest of it out. Well, I couldn't figure the rest of it out until that bug was happening and the whole code broke. So it was eventually sorted out in the end, but they cascade rather quickly, so you need to kind of nip them in the bud as soon as you can.
Oh, and then I guess another thing too is to make sure that you start things early and get things done, because you might think that you're close to being done with something, and all these other problems emerge, and just make sure you get ahead right away. So that would be a good lesson, or I guess something to say, tell other design groups. So here's just a little kind of a chart of our final product, kind of the price breakdown for all the parts. The PCB print and enclosure, that was just more of an estimate. But you can see that without mass production, it did cost $56.38 to produce. But I mean, all of these components, if you bought them in quantities, greater than 1, the prices went dramatically down. So
yeah, the PCB print alone would save you almost, well over half of that cost if you bought it in bulk.
You could probably get this under sub $20 if you mass produce this. Not even counting labor for code, because once that code's done, it just flashes to everything. So it'll be pretty cost effective if you were to mass produce this. Closing statements. This was pretty much our first real world taste of a deadline-based project. Definitely learning experience. You, like we said before, you never quite have as much time as you think you do. And I know you reiterated that several times in emails, but you don't really appreciate it till your butt's up against a deadline and you realize I probably should have taken care of this a lot sooner than I did.
And not to mention that clients never get back to you quite as fast as you like them to.
Yeah.
Usually measured in days.
Hours.
And yeah, it's just good to be constantly, having that communication so you can get updates on, both sides. It's really helpful to make sure that you have all of their requirements in mind, and any updates that are made to those, you want to get those as soon as you can.
And finally, about how designs can change very shortly, because in fact, our first semester we went with a completely different route, different hardware, with a company called CSR. They're not as easy to work with as we were hoping to be, so we actually had to go down the Arduino side this semester. So we essentially, hardware-wise, we completely started over this semester. So
worked out in the end.
Yeah.
That's it.
All right, thank you.